Good afternoon, everyone. So, are you all ready to go with our next topic? Okay, you should be ready, right? Okay, so let's see what is our next thing. In the last session, okay, we had learned few patterns, right? Like we studied about this if a natural number. We basically studied about fifth and the sixth, right? We studied these two patterns. Today also we are going to study pattern. Okay, solve few questions on them, and then we will move on to the next topic. Okay, with the next classes. Okay, future class. So what's the next seventh pattern? 1 square plus 2 square plus 2 square is equal to 3 square. Oh, what's it? 2 square plus 3 square plus 6 square is equal to 7 square. 3 square plus 4 square plus 12 square 13 square. So in this, you might be seeing that this is 12. It's next square. Right? You might be thinking. But it shows that we can express the sum of the squares of any two consecutive numbers and their product. Sum of any two consecutive numbers and their product in terms of n. N is a product of two consecutive numbers. Okay. So the first numbers we are going to take over here, these numbers. Okay, these are two questions to be answered by you. These are few questions. Okay, it needs to be answered by you. So what it says. So here n, what is n? The product of these two numbers. 1 into 2 is how much? 2. 2 plus 1 square is equal to 3 square. So this is 3 square. Next, 2 square plus 3 square. What is that product? 6 square plus 1. 6 plus 1 square. 7 square. Right? 3 into 4, 12. 12 plus 1, 13. So it's 13 square. It's saying like that. Okay. So n, sum of the square of any two consecutive numbers. Any two consecutive numbers, if we are going to do with this, their sum along with their product, it will be n plus 1 square, where n is this product plus 1. Simple. See, we'll solve few sums. You'll be able to understand it better. 4 into 5. First, we have to multiply. 4 5s are 20. So here it will be 20 square is equal to 21 square. 5 square plus dash square plus is equal to 30 square. We have to think. 5 into 6 is equal to 30, and square as it is. It will be 31 square. 6 plus 1 plus 6 plus 7. Sorry. 6 into 7 is 42. 42 square. It will be equal to 43 square. You want me to explain it? See, if you have the numbers 8 square plus 9 square plus what will be over here and what will be over here. 8 into 9, 72. 72 square. And this will be 73. Just next to this. And this will be multiplied and you will get this. You will multiply the two numbers, you will get the third number. And when you add all these, you will get the successor of the third number. It's simple if you just understand the concept. The eighth pattern, another interesting pattern. It says 7 square is equal to 49, 67 square is 4, 4, 8, 9, 6, 6, 7. Okay, so what do you observe? The digits 4 and 9 in the first and the last respectively are common. Right? Just what's being added here? 8 and 4. If there are 2 6, then there will be 2 times 4 and 2 times 8. If there are 3, it will be 3 and 3. If it's going to be 4, then 4 and 4. This is going to be 5 and 5. So if we have to find square 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 square. You're not going to do, it's going to be a trick. It's going to be a simple trick. That is 4 will be common over here, 9 will be common. 10, when we do, how many times now 4 will come over here? In between? In between, how many times 4 will come? Yes, 10 times 4 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many times 8 will come? 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be the answer. Oh my god, it's very lengthy. So shall we solve few questions so that you get clear with it? Observe the following pattern and supply the missing numbers. I tell you that patterns are not to buy heart or mug up or anything. They are basically to understand, like a logical reasoning. 11 square is 121. 101 square is 10201. See, if 1 square comes here, we are going to add 2 zeros between 120. If 2 squares, then it will be 3. 1 to 3, 2, 1. Oh, so it's a pattern. Let's see how. 1, 2, 3, 4. Here 4 times 1 and 3 times 0, right, in this square. So what are we going to do? 1, 0, 2, 0, 3. If there are 2 zeros, there are 4 zeros. So if you have 3 zeros, there will be 6 zeros, right? 2 twos are for that side. The twos are 6. 1 twos are 2. So here 6 zeros. 1, 2 are over 0, 4, 0. 4 zeros are over 3, 0, 2, 0, 1. So 1, 2, 3, 4, 5, 6. Just going to increase it and then ascending order and then descending. Okay? Same way. What is going to be how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 8 by 2 is 4. So over here there will be 4 zeros. 1, 2, 3, 4. It will be 1, 0, 1, 0, 1, 0, 1, 0, 1. That will be the answer. If you observe it, in a keen manner, you'll understand. Okay. Without adding, find the sum. This we had learned. No need to add 1 plus 3, 4. 4 plus 4, 4 plus 5, 9. 9 plus 7. No, that's not at all required. The simple thing which you have to do is count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. It will be equal 12 square. 144. Without adding, we have found using the patterns. Okay, so I hope you are clear with the patterns, right? Which we had studied in our previous classes also, and today also we learned about them. I hope you are clear, right? Few patterns we came across, and remember, you don't have to, right? So I hope it's clear to you the patterns. The next thing we are going to go with Pythagorean triplets in our next class. Till then, bye and thank you.